This is a continuation of part 1 of the presentation on the eppd library. This part details the use of the library to create HVAC systems. The library enables assigning new systems to zones and configuring central plants. The first step in this process is to create a system definition data frame. The data frame should include columns for the zone name, the system name, air loop type, zone system type, and the system fan schedule. The data frame seen here shows a sample layout. It includes all the zone names from the IDF file. The program assigns the zones with the same system name to a single system. This layout can be generated with a Python script or can be loaded from a CSV file that has the required columns. The air loop string consists of a cooling coil type, heating coil type, and the system type code. In the first example, we have a DX cooling coil, natural gas furnace, and a constant volume air loop. The second example includes a DX coil, heat pump for heating, with a VAV type air loop. The third example shown here creates a DOAS system with chill water and hot water coils. The zone loop definition string consists of a zone system type code and a baseboard type code. The first example shows a VAV box with hot water reheat coils in the zone. The second example represents a constant volume air distribution system serving the zone. The last example here shows the code for a chill beam unit with hot water baseboard. The system definition data frame is then passed to the createSys function along with the IDF model. The function then returns an IDF model with the new systems applied. Systems needing a central plant require setting up of a plant config data class. This creates a definition of central plant equipments for the loop. The PlantSys namespace provides a list of available central plant equipments. Code editors can list the available equipments in this namespace. In this example, a central plant with a gas boiler and an air-cooled chiller is created. The central plant definition is then passed to the createSys function to apply to the new systems. This slide shows the EOI comparison of all the simulation cases that were set up. In summary, we saw how HVAC systems assignments are set up using a simple data frame. Air loops are created using a string. Setting up of zone systems with a string. Define central plants with the discoverable namespace. And do a full HVAC replacement with a few steps. This slide provides some notes to go over by pausing the video.